You start the lab by opening the supplied package. A package is a package of files that includes all the files required for the lab. So click Open, select the ROBT3341 Lab 3 starting. So it's RSPAG, so RobotStudio package file. Click Open, it will unpack it. You can leave it at the default or select a folder of your own. Click Next, and all the defaults should be good. And click Finish, and you have to wait a few seconds while it unpacks. You can create these packages, and that's what I want you to do at the end of your lab when you hand it in, by going to the File menu and clicking on Share, and it will gather all the files together so that ensures that when you pass it to someone else, they get all the files required to simulate the robot. And we'll just have to wait a second here while it unpacks. And it's finished, we can close it. So here we have the station, got our controller status. We can close this one for now. And we've got two pieces of paper. They'll be supplied in the lab, 11 by 17 paper. And on one, we're going to place the objects. These are the standard wheels or blocks that we're going to pick up. And on the other one, we're going to pick up from here, and then we're going to pick them up and place them over here. They're in a linear pattern here, and we're going to place them in a circular pattern on this piece of paper. We're going to do a few things here. We're going to start out by bringing in a gripper. So we have our gripper. I've defined a gripper for you already. So all you need to do is bring it in and attach it. Then you'll create a couple of work objects. We're going to create one work object for this piece of paper for the pickup, and one work object over here for this piece of paper for the placement. After that, you'll create a few robot targets, and then you'll create a new program, and you'll write the rest of the program to perform the operations. We're also going to simulate the inputs and outputs, so I've created some simulated inputs and outputs for the gripper. So we're going to start out by attaching or opening and attaching the gripper. And notice all these tabs across here. We're going to be using several of them, mostly the Home tab. And there's a second set of tabs here. There's a Layout tab and the Paths and Targets. We're going to be using both of those. We'll use the Simulation tab a little bit, Controller tab a bit, and the Rapid tab a lot. So the Rapid and the Home tab are the main ones that we'll focus on in this lab. So let's start out. I have created the gripper as a library component. So we come here and we'll browse for library. These are all the standard library components that come with RobotStudio. But I haven't placed mine in any of those folders. I've just given it to you. You've placed it in a folder. Find it. It's tgripper.rslib, so RobotStudio library file. Open that. And you probably can't see it because there we go. It's hidden down there in the base of the robot. It comes in at its default position. But once we right click, attach to, we'll attach it to our robot, and we want to update the position, yes, and there we go. So now we have a shunt gripper with gripper jaws that approximate our gripper and jaws, and the TCP is defined right at the end of the gripper jaws. Might not be the optimum place for it, we'll see later, but we can certainly work with that. So after we have the gripper, then we're going to teach two work objects. Like I said, one at the corner here of this paper and one at the corner over here on this piece of paper. There are several ways to create work objects. We don't really have to rotate them or do anything fancy here, so we can probably do it this way. We go to Other, Create Work Object, and we give it a name. So I'm going to call it WObj, let's see, Paper Pickup. And we'll make another one later called Paper Place. The user frame, so we'll change the user frame, we'll leave the object frame alone just like we did in the last lab. So position and rotation, I'm just going to do the position. And for values, If I click that, I have to enter the XYZ. Well, I don't know what the XYZ position is right now, so the easiest way for me to do it graphically is just snap to that corner. So up here we have all the selections. So I'm going to select surface selection because the white paper is a surface. And then I'm going to go pick snap N for endpoints. After I've picked it, I can't just go and snap on the paper. I have to go and click back in the dialog box, so the cursor's in the dialog box. Then I can go here, and you can see the dot appear there at the corner. It's snapping to the endpoint. So we'll snap at the endpoint. It gets the XY position. I can accept that. Now we've got our values in there, and I'll create the work object. So we probably don't need to go back to this layout tab anymore. We can go to the paths and targets. Notice what's happened now. Under our task, we have tool data, T gripper. That's when I attach the gripper, then it attached that tool, and it defined that T gripper tool data as well. If you notice here as well, up in settings, we've got the T gripper as the current active tool because as soon as I attached it, it made that the active tool. Under work objects and targets, I have a work object paper pickup, and it makes that work object active. I can go back to work object 0 if I want, or any other one that I have. So we want to keep an eye on that. These also display down here at the bottom in the status bar, and these other options here are the current default move commands and options for when we create a path, which we'll be doing in a minute. So we've got our first work object. We want to create a second one here. We can do the same thing. Create work object, paper, place, and click here, get our dialog box. We've still got the correct selection, so I just put my cursor in the dialog box, and I'm going to pick here. We'll accept that, create it, and now we have a work object paper place here. Now we have to make sure that when we create points or targets later on that we have the correct work object and tool selected. So I'm going to start out by creating a target over here on this block. That's our first block that we're going to pick up. That's going to be with respect to work object paper pickup. So I better pick the correct work object here. All right, so let's go in here and create a target. And again, over here, we've got work object paper pickup. It's active. It's highlighted right now. So to create a target, we can create target. We can create a joint target or create targets on edge. We won't be using those. Typically, the create target one is what we'll use here. I've got on surface selection, I want to get the center of the block. So I'm going to pick snap center. Again, the focus is taken away from the position dialog, so I go click in here again, make sure the cursor's in there. And that's it. Point 1 has been added. I can give it a name here, target name. Don't worry if you forget to do this, you can go and rename it in a minute. I'll show you how to do that. So we were using P for points, so we're going to go P first block, or you might come up with a better name. We'll leave the orientation alone for a sec because I want to show you a few things about that. And we're just going to create that one. And you can see I can create an insert move instruction immediately, so I can tell it create this target and a move instruction to this point, but we'll do that later on. So create that, close that, and let's see what we have here. We see here now we have P first block, and it puts an underscore 10 on it. We can rename that. In fact, I'm going to do that right now. Right click, rename, P first block. So we've got a little warning here, the configuration is not verified. So because we're teaching it graphically rather than moving the robot to that location, it doesn't know what configuration the robot should have when it goes there. Remember, there's multiple configurations when we do the inverse kinematics. We have to tell it which one to choose, which means that we have to tell it a specific configuration. If I right click now and click on configurations, there are no valid configurations for that location. That means that the robot cannot get there. So why can't it get there? Remember what happens when the robot moves to a location. It wants to align the tool axes with the target axes. There's no way that it can align that z-axis with this z-axis because it would have to come up from underneath and it can't get there. So we need to rotate this target. We can rotate it about the x or the y axes. Additionally, I'd probably like the gripper so that maybe the green axis of the gripper, that's the y axis, maybe points that way. So the gripper jaws are on either side of the part and we don't touch this part as we're picking up this one. So let's look at rotating this. I can right click and notice as well we've got no configuration found here. We get this little red mark. So I'm going to go here now and I'm going to go down to modify target, rotate, and we can notice that we can move it, we can rotate it, we can place it using multiple points. So I'm going to rotate first about the x-axis by 180 degrees and apply that. Now the robot should be able to reach there. But I said I wanted this green axis, the y-axis, to point out on an angle to match kind of the angle of the blocks. So let's rotate about the z-axis. And let's just rotate maybe 45 degrees at a time. No, no, and there we go. That's where I want it. So I can close that now. And let's check the configuration now. Right click, configurations, and now we have a configuration, one configuration only that's possible for that robot. So let's click on it and the robot will go there and that looks fine. So if I apply that configuration, notice that now we're all fine, no errors. So the robot can get there. Now you'll notice something else if I rotate around a little bit, zoom in, and so the TCP is now in line with the target. However, we're not far enough down. Now we could adjust this later in our program by just adjusting the Z value of the target, but we can do that here as well. We can do it graphically. So we want these jaws down a bit. Let's say we want to move the target then down about, halfway down here. Let's say 12, 15 millimeters, something like that. So let's move the target down. So right click, modify target, set position, and we want to go down in the positive Z direction, let's say 12 millimeters. And we'll apply that. And you notice it's moved down. And again, we get the warning, so we have to right click, configurations. There we go. So anytime we move, rotate, or create a target, we have to make sure that we select the correct configuration for the robot for that target. There's lots of tools you can use if you have multiple targets. You can copy the configuration, so you don't have to actually do this for every single target. So it looks like we've got a valid position now. And what we can do is we can right click and we'll add to new path. And it creates a path 10. We can rename this if we want. And it puts a move L to P first block. That's not exactly what we'll want. We probably want to have an approach position and ahead of that and maybe a few other positions in there and a few other things. But you'll see we can do all that later in our program. Notice what it used. It used a move L, and if I hover over it, it'll tell me the entire statement. But it uses these settings down at the bottom as the default. So if I change any of these, if I wanted to join interpolated move, I would just pick move J from the list instead of move L. And also it uses this work object and this gripper, and we can change those here at the top under settings or down here on the status bar. Let's just select another location. We'll call it kind of an intermediate point for the robot. And if I've got my robot, I can go in here. I can go to jog linear or I can go to jog joint. So I can grab individual joints of the robot. I can rotate it around. Maybe we'll zoom out a little bit. Pull that one up. And somewhere there. And we'll call that our intermediate point. So we'll pick, we'll come back to the intermediate point, and then we'll place, come back to the intermediate point, etc. So our robot's all in position here. This one really isn't with respect to the object paper. I'm going to make it with respect to work object 0 instead. So if I move the paper around, this position doesn't really move. And I can go and I can create a target, but the easiest way to do this one is probably teach target or even teach instruction we can do. So you can see what it says for creating a move instruction and corresponding target at the current position of the robot. So let's do that. It's giving me a little warning about work object 0. I'm okay with that. And you notice that it's put in move L target 10. So again, that's something we can go and change the name of later. In fact, I can do it right now. We stored that one under work object 0. You notice that we have no configuration problems because I actually moved the robot there and said just teach where you're at with the current configuration. So I'll rename that and we'll call it a P intermediate. And you notice it renamed it automatically for us down here as well. And I probably don't want to do a move L to it. I can change that later in my program quite easily. I can also do all sorts of things here and modify instruction. So instead of a motion type linear, I can go to a joint. I can change the speed here, the zone data. So let's say I'm going to go to a zone 20. Again, you know, if you feel more comfortable, just type it in later on when you work with your program. So I apply that, I close it, and we've got to move J now. And we can move these around. So that one moves down to there. So I'm going to move to that one first, then down to there. And then I can copy that later when I write my program. So once we're at this point, we've got a couple targets, we've got our work objects done, we've got some paths. And the reason I create those paths is I can't really copy these points over to my program unless I have them in a path. So now I'm going to go over the Rapid tab. And there's many ways to create a new program. We go under the, one way is to go under the task and we'll just right click and we'll click new module. I'll create a module and then inside that I'll create a main routine. The other way you can do it if you want to try it this way is simulation setup. And I click entry point and I want a main procedure and I want to create it in, I've got my two existing system modules or my new module that I'm going to call Brent main module. And click OK. If we go to the Rapid tab, we'll see now I have a Brent main module. Double click on that and let's see what's in it. It should be empty, but it should have a main procedure already defined. So we're ready to go. We've got our proc main and we've got our main module. Let's format that. There we go. That indents it nicely. So now I've got my empty program. And again, you can do this later if you want. It's just easier if you do it now because it helps you organize things so you don't have to reorganize them all later. Now on the synchronize button, we're going to synchronize to the virtual controller. So all the work we had just done was in the station. Now we're going to synchronize to the virtual controller. This is going to send it to the virtual controller, which means that it's basically like the real robot, only it's the virtual robot and its controller. It can be a little bit confusing until you kind of get used to this sequence. It's saying, where do you want to store the gripper data, the work object data? Well, it suggested I'll make you a new module called calib data for calibration data. We say, no, we don't want that. We want to put it in Brent main module. Well, if you want it all in your main module, you can do that. If you want it in the calibration module, that's a good place to put it as well. It keeps things organized. Where do you want path 10? Well, I'm going to put it in my main module. And you can see under here we've got the 2 points selected as well. And where do we want those stored? We're going to put those in the main module too. And they're going to be stored as constant. These ones are going to be stored as persistent or task persistent. Task just means they're only available for the task. Since we only have one task, it doesn't really matter which one we pick here. Click OK. And what do we have? We got all our data came across. We've got our main procedure, and we've got our path came across as a separate procedure. So you notice it's got a move J and our move L in there. I've got my 2 points. I can do anything I like now. From a rapid standpoint, I can just start programming and do anything. So main is our entry point. If I want to keep this path 10 here, I can rename it now. I can do whatever I like. So I need to call it from somewhere. I'll just leave it for now. We'll call it path 10, and from our main we'll just call path 10. Format everything. And why don't we go run this? What I'm going to do is I'm going to Control C, Control V, take it back to intermediate afterwards. Of course, we'd probably want to put an approach point in here. Probably want to slow this down a little bit. This is probably going to be a fine. We want to use T gripper. Yes, yes. Everything else looks good. Okay. So now we want to run it. Well, first of all, we apply our changes. And then we've got start up here. We've got check program. No errors, it says down here at the bottom. That's fine. We can put breakpoints in. We can do all kinds of things. As I showed you, we can format. So I'm going to try to run it. Start, and it says not allowed command. Operation not allowed by the safety system. Please use the control panel to change to auto mode or verify that. So we got 2 choices here. We can either stay in manual mode, which means we have to run it from the teach pendant. We can do that because we know that we can look at the virtual flex pendant and we can run it just like we do in class. Remember, this is exactly the same as you do the real robot. So I can show the virtual flex pendant, push the enable button, and then step through the program or run it from the flex pendant. In this case, though, what I'm going to do is I'm going to put it in automatic mode and let it run in auto mode. So again, from the controller tab, I'm going to click on the control panel. This is the front panel of my controller. I'm in automatic mode, but the motors are off. I need to turn the motors on. Auto mode, motors on. Manual mode, auto mode, motors on. That panel can stay there if we like. I'll go back to rapid. I'd like to see the robot moving, so I right click on this tab right here, and I'm going to click new vertical tab group. And it'll show me my robot beside my program code. And now we should be able to start. And there's our robot executing our move L to the first block and our move J back. So the move L is really slow because I got a V100, and then the move J back is quick because I got a V1000. You notice that it keeps doing it over and over and over. That's because we have our run mode to continuous. So I'm going to change our run mode to single cycle. Now it should stop at the end of the cycle. There we go. Okay, a few other interesting things here you can do just briefly before we finish up here. So no problem there. We can step in, we can do one line at a time. We can put in breakpoints and stop at the breakpoint. We can change our program pointer, go to main and all tasks, which is typically what we want to do before we start running it. I can run it in manual mode from the flex pendant, everything that I can do on the real machine. A couple other cool things here. So simulation, I/O simulator, really neat. We've got a few I/Os defined. Outputs, we'll see these change if I turn the outputs on or off. Inputs, we can monitor inputs, and I'll show you that in a second. We can also, under monitor, I can enable the TCP trace. and it'll show me the tool center point, and it'll leave it as a trace on the screen after we're finished. Back to Rapid. Now we've got lots of windows open, but a little bigger screen area, and it's no problem. So we're in automatic mode, we're ready to roll. Okay, I'm going to throw a command in here. We'll move to the intermediate point, and before we go further, I'm going to do a wait DI, and I'm going to wait for, as soon as I press D, I get my choice, DI10 underscore 1, so input 1 to be a 1. And after, I'm going to set DO space, press D. Okay, I'm going to set DO 13 to 1. So let's step through this now and see what happens. Actually, let's just run it. So I'm going to apply, just like we do on the real one. Apply to save my changes. Start. What's it doing? It's waiting. Waiting for digital input 1 to be 1. So let's make it a 1. Let's simulate that switch being closed. There we go. Now it goes. After it's finished, that was a fine, so it should get all the way there before it turns on the output, and it did. So what I like to do here, just as a one additional tip before we go, and notice the trace here, by the way. One additional tip. What I like to do, I like to copy, Control C, and paste it into Notepad or something else so that I always have a copy of it. Because as you go back and forth here, you might want to make some changes. You'll create some more targets. You want to add them in. You can, when you synchronize here, changes you make here, you want to synchronize back to the station. The station is when you're in the Home tab and working in the graphical layout. This is the station. So when you're in here, either from the Rapid tab or from here, you want to synchronize when you make changes and make more points or change work objects, etc. You want to synchronize the virtual controller. What can happen, and I've had this happen to me because, of course, we're all new at this, and it's easy to do. You'll overwrite what you've just done here. So that's why I like to have a copy of it in Notepad or somewhere else. So if I do accidentally overwrite it when I synchronize back and forth, I can always recall it and just paste it here again and keep working with it. Okay, so that concludes our video, and there are various other videos available for RobotStudio online, so you can have a look at those. Also, I posted the RobotStudio training materials, so you can have a look at those. At the very end, once you're all done, then what I've asked you to do is I've asked you to save your module, and I want to see your module with all your targets and your work objects and tool data definitions and all your program, of course. I want it nicely commented. And then as well, save your station, and then do a share and pack and go your station. So you can pack standard libraries, do everything. So turn that one off so it does it. It doesn't not do it, so it does do it. So copy it, next, and you'll create the package, and that'll be a RSPAG file, and that's what I want you to submit along with the module files. Okay, so that concludes our video for Lab 3.